Finding the averages from the frequency table. In this screencast we're going to look at the mean from the frequency table, the mean from a frequency table with interval data, the mode from the frequency table, and the median from the frequency table. The mean, just a reminder, to find the mean, it's the total of the data and you divide by the number of data items. So for instance, for 12 young people at a McDonald's party, you would find the total of their ages, which is 142, and you would divide that by 9 and you get 15.8 when you round off to the one decimal place. There's another way of finding that total. You could write 12 times 3, 15 times 1, plus 17 times 2, plus 19 times 3. Those numbers, the 3, the 1, the 2 and the 3, are effectively like frequencies. There were 3 12-year-olds in the group. That leads us quite nicely into the idea of using a frequency table to find the mean. Here's some data of the kind you might find in an exam question. A small company was monitoring absence for a 3-month period, and 12 staff had no absence at all, 14 staff had 1 day away, and so on. The days absent is the variable, that's what you're trying to find the mean of. The number of staff is the frequency. You've got to spot which one's acting as the frequency and which one's the variable, otherwise the question becomes impossible to answer. Now remember what we did with the ages of the children. We're now going to multiply each number of days absence by the number of staff that were absent for that period. So nothing times 12 is nothing in the first column, 1 times 14 is 14 in the second column, and so on. Those subtotals we can then add up to find 186 days of absence. But we have to add up the number of staff, the frequencies, to work out how many people were taking the time off. So the mean is 186 divided by 78, and that comes to 2.38, just over 2 days. With interval data, here's some interval data. We do something slightly different. Suppose this was the height of cress plants grown on one of those bits of blotting paper. Mine never used to work, they used to go mouldy, but you get the idea. We can again multiply the height by the frequency, but the height's in intervals, so what we do is we take the midpoint of an interval. So you see how the first interval goes from 10 to 15 millimeters? Well, halfway is 12.5. You can add the 10 and the 15 together, press equals and divide by 2 if you want, or just split the difference. The second interval has a midpoint of 17.5. Now you see how the pattern repeats again for the third and fourth intervals. That's quite common. Well, now we treat the midpoint as if it's actually the data item, and we multiply the frequencies. So you see 7 12.5s is 87.5, well I sincerely hope it is. 12 17.5s is 210, and so on. Just like the first example, now we add up the subtotals, and we add up the frequencies first to find the number of plants we got, then we add up the subtotals. And the mean is given by the total length of all the cress seedlings put end to end, which is 717.5 millimeters, quite a long bit of cress, divided by 37 cress seedlings, and you get 19.4 millimeters as the average height, or mean height. So you see the idea. The main idea is to get the midpoints and then multiply them by the frequencies. On exam questions on tables like this, some of the values are quite often filled in, so you can usually work out what's going on. The mode. The mode's kind of one of the simplest averages. You're basically looking for the most common value in a data set, the one with the highest frequency that translates into. So here's our cress seedling data. The one with the highest frequency is the 15, so we can say that the 20 smaller than height, smaller than or equal to 25 millimeters, is the modal class. You can't actually say any more than that, you can just say that is the modal class. The absence data, because it's discrete data, we can be a bit more accurate about this. We can say that 19 people were absent for 2 days, and that's the largest frequency, so 2 days was the most common absence period. So that's 2 days modal absence compared with 2.39 average, mean average. Okay, that's all there is to say about mode. The median is slightly more complicated. Remember that the median is the value of the middle data item when you put the data in order of size. Well, of course, a frequency table does put the data in order of size. So the smallest 7 cress seedlings are in the first interval. So what we do is we find out the total of all the cress seedlings, that came to 37, then we halve it, that's 18.5. So then we find a cumulative frequency total of all the frequencies. So you see how in the second column we've got 12 plus 7 makes 19. In the third cumulative frequency space you've got 15 plus 19 makes 34, and in the fourth cumulative frequency space you've got 3 plus 34 makes 37. So that cumulative frequency row is like a running total of the frequencies. We'll talk more about cumulative frequency later. Now, which cumulative frequency is the first one that's just higher than 18.5? Well, the answer is it's 19. And that means that the median cress seedling is somewhere in the 15 to 20 interval. We can't say precisely where. It's probably near the 20 end, but we don't know how the cress seedlings are broken down through that interval. So to recap, you take half the total number of things that you have, you do a running total of the frequency, and you find the first one that's over halfway, and then you read off the interval. Applying the same ideas to the absence data, we do the total, that's 78. Half of 78 is 39. Remember 39. Now we do our running totals. What's the first number in the cumulative frequency row that's just bigger than 39? Well, the answer is 45. So that's the column which contains the median value, and the median number of days absent was 2 again. So we had 2 for the median, 2 for the mode, and 2.39 for the mean. Summary. To find the mean, you multiply the midpoints by frequencies and add the subtotals that you get. You divide by the total of the frequencies to find the mean. Mode, you find the largest frequency, the corresponding value is the modal value or modal class. Don't fall into the trap of writing down the frequency as the answer. The median, you calculate a running total of the frequencies, and you find the first interval where the cumulative frequency is just over half the total of the frequencies, and that interval contains the median. Your turn. Any GCSE maths textbook will have a load of questions about this topic because it's a perennial favourite. Work your way through a good chunk of those questions, and there'll be certain edge cases, certain unusual problems that you're asked to solve that will help clarify the issues. And that's it.